what I want to do is today we will do a group work on Moodle. So this one, everyone has to input the answers on the computer, but of course you can discuss it with the computer. That's kind of the point. But before we do that, I want to give out this sheet because I want you all to practice just filling in some formulas. So this is what you will see. Let me give this out first. So it should not take you that long because there's not much. I want to do half of it first. I only want you to work on this part, the proportion part. You don't even know what a mean is right now. So just do this part brief. When you are testing for a proportion, right, what does the null say? What symbol goes here? Just tell me what you think. We will answer this in spreadsheet as well before we do the group work because you will need these formulas in your group work. All right. So right now, this is some symbol, and then give me the formulas for sim z and theory z. You can check your books. It's fine. Right? I want you to have these formulas ready and just write them. And then tell me where the p-value comes from if it's a really one that you want. Right? Which table did you learn to look at? Just give me the name of the table, all right? So when you are happy with your answer, I would encourage you to put them here, okay?
Are there any extras?
Oh, yes, I do have some. How many do you need? One? Okay. So try this out. Look at your notes so that you can find any missing formulas that you might not know. But it's quite important that you have these formulas ready. All right. Now here, give it to me generically, okay? Because there's no specific situation, so give it to me in the most generic. In other words, all symbols, no numbers at all. All right. Then you hold on to this piece of paper because after we have done the group work, then I'll ask you to do something else with it. So we'll do this in two parts. All right. Very good. In the proportion situation, the only observed statistic they've seen is p hat. Very good. Do you know how to fill this in? What does the null look like in a situation where you have a proportion? What symbol goes here? Just give me a symbol, all right? I mean, you can type the symbol. Right? You don't have to give me the actual symbol. You can type it out. That's right. The null says that pi is something. I don't want to say 0.5 because it doesn't have to be 0.5. If you've done your homework, there's all kinds of things pi could be. This is the important status quo thing I was talking about. Let's ask you some. In fact, maybe we can help the class. Can you color the word PIE? What color should pi be? We try to use colors to teach in this class. What color should pi be? I'm trying to make this a thing so that you can connect things more easily. And what color should p hat be? And then, all right, because this is to help everyone really be comfortable with these things because these concepts will get repeated again and again. So what color should pi be? What color do we use for the hypothesized status quo value? As I said, it's like comparing the price of eggs. This is the established status quo price of eggs, and p hat is the new price of eggs or something like that. We are comparing the new price to the old price. That's right. This should be blue always. The hypothesized value is always blue. And the observed is always observed is always red. Very good. Very good. And if you want, you can go on. These are all correct, by the way. P hat minus pi c, they share the same numerator, but the denominator here comes from the. So I'll just add a few words. This SD you will only get when you simulate SD of the simulated null distribution. It's very long, but you only get it when you simulate. What color did we reserve for these SD things? And everything is correct, by the way. What color do we use for the SD? We try to be consistent in this class so that we can keep track of the quite a few numbers running all over the place. Always green, good. And you can color this whole thing green as well because this is an SD. The whole thing here is green. This is the green thing. This is from theory. This is from simulation. See? Good. Uh, if you want, I think it will be helpful. I will color these in as well. So this is red, right? This is red. And this is blue. Very good. All right. Okay. So let's just answer. I think the hard part is all done now. Do you know where the sim p-value comes from? And where does the theory p-value come from? This one, I would be very interested to see if anyone knows how to answer this one. Okay? And what color do we reserve for p-values? This has its own color. Blue, red, green are taken. What color did we introduce for the p-value? Very good, purple. So I'm going to do that. I'm trying to show you that whether it's simulation-based or theory-based, they are both p-values. It's not that one is not a p-value. They are both p-values. Very good. I've actually had students, right, who don't know this. We spent the first class talking about the Z table, but it's evaporated already. So yes, theory p-values come from the Z table. Why is it called the Z table? Because you calculate a Z statistic. You get the statistic, then you go see the table. Now, simulation p-values is a bit more abstract. It didn't come from the table. And I think I wouldn't blame you if you say, simulation p-value comes from the picture. Yes, okay. But what about the picture? So I'll help you out here. The sim p-value comes from counting the fraction of cases which are more extreme than what you observed. This is more difficult. There's no easy, short way to say this. The simulation p-value is a fraction of cases more extreme than what you got. Does it make sense? This is putting it in words, what you see on the screen as a fraction. If you've done your homework, it's always just 1 upon 1,000 upon 1,000, but you always do 1,000 simulations. Is this okay? What I'm trying to get across to the class is that these two are both p-values. It's just that one comes from a simulation standpoint, one comes from theory, and they are close. Again, I've said this phrase so many times. If you've done your homework, did you find that your theory p-value and your sim p-value were close? They should be. They should not be, 1 0.9, 1 0.1. That's bad. They should be both close. Not exactly the same, but close. All right? Okay, so hold on to this because I now want you to start group work 2. All right? Group work 2, I believe, is the first time we are doing a group work that is more okay, let me explain. I'll give you a few hints, all right? Be very clear. What's the blue number? What's the red number? And where is the green number eventually? Which one do you use? All right. And I'll start you off. If you read the question, in February 2012, there was a bill introduced in the Senate that would outlaw smoking when young children are present. Okay. So that same month, okay, they asked selected Ohio voters. Of the 1,421 respondents, 61% said it was a good idea. We want to investigate whether more than 60% of all Ohio voters think this bill is a good idea. Now, do you understand the situation? There's this bill that was introduced, and people want to know how the public's perception is on whether they think the bill is a good thing. Okay, and this was in 2012, so some time ago. Now, anyone care to tell me, first of all, what do you think is the red number? What's the observed? I don't mind saying there's a p hat here. What is the observed p hat? Anyone know the answer? Yeah. That's the sample size. Good. That's observed. Yes, the sample size is 142. Good. What's the observed p hat? What is the observed fraction of people that thought that the bill was a good idea? Observed. Yes. 61%. So I told you there's a blue number there, but it's not, I don't tell you what it is, but reading the question carefully should tell you what is the status quo thing that we are comparing to, the unknown thing that we are hypothesizing. Anyone found it yet? Do you see it? It is also a proportion. Yes. That's right. So I chose this purposely because these are close. What I'm saying is this, the 61% is observed, you cannot do anything about it. But I choose to test whether there is any evidence that 60% of Ohio people in general think it's a good idea. This number is chosen by me. You see, it could be chosen by you to be something else. Can I test whether 59% of Ohio voters think it's good? I can. The blue number is always harder for students to grasp because status quo is set actually by the researcher. What are you comparing it to? So correct. Status quo here is 60%. How do we know this? Because actually this is telling you the alternative hypothesis is a greater than 60%. Does that tell you what the null is? Do you realize that the null and the alternative always share the same values of the numbers? You don't have a null and an alternative that have different numbers. Yes, the null is the one with an equal sign. The alternative is the one with either greater than, less than, or not equal to. But they share the same number. So does this tell you what the blue number is? It should. And you've already told me what the red number is. So I think you're ready to do this assignment, okay? It does combine a few concepts. I think time is not the issue because I gave you 20 minutes on this. So you can start, right? And just do it as carefully. I want to see how well you do on this, all right? Because I want to know where you all stand at this time. It does combine a few concepts from all the previous work that you've done. So give it your best shot, all right? You will need the applet. You will need the applet, but later, not yet, all right? Yeah. So when you have the unknown, maybe you see the efforts. How do this always if you are confused about this part, this is actually the applet. What do you fill in thing, all right? You know the boxes, the applet. So that's why is what is in the context of also another hint when you are using the accent, make sure you are in proportion mode. Make sure you are in proportion mode. So that's part of what all these goes in. So it's asking the answer. 0.61 has a place on this picture. Where do you put it? So have you established what is the computer?
That's the last one. Oh, why is there yeah, but the sweet turn negative. No, it's not.
I think somehow I'm close because I really want to best for you. I'm just testing the.
Is that what it gives you, right? Yeah.
Are you sure that that's what I got. Okay, so from here we have to enter.
There's a 0.6 more.
Right.
That's heavy, right?
And then.
No.
I literally almost just did.
Oh, I did.
But. Okay. So.
Well, I did. Wait, what's it all have?
Really? I haven't even looked at it yet, so I'll let you know.
I think it is, yeah.
That's 0.49 thousand. Enough. Oh, it's a P value.
Okay, wait, so.
Oh, it's like 6.
Divided by.
Are you trying for with
Do you have evidence to reject?
Oh, I got it. This is
What about they move on?
We just look at the.
No, that's it's still peak minus pi.
So we do need this
Divided by the square root.
Is that not the same thing? Yeah, I think it's based on credit. Okay. I think it's like there's lots of.
The total is the total. So,
Yes.
it's the same number. Is it really? It's 7, 6.
It gets.
Yeah.
Is anyone else?
7, 6, no, 5. Three base, P dot base.
I don't know if this.
Oh, but it's
So for that fail, so we like.
Okay. That's fine. Yeah. Oh, and we didn't get which one are you going?
Since she cited.
Yeah, I got it.
I know. Bottom line is that's.
I think that's what. Yeah. It's like it has to be the same as that. Yeah.
So that's where they're gonna say that
There's some careless,
but.
oh, It's 0.76.
Oh. Yes. You round it, but then don't round it to very big. So this is for this one. Side because if the things are always to see that side, but it's what is your thing? Oh, oh, it's pretty. Yeah, so no, these. Yeah, leave them until math, but for the table, you run, okay, okay.
You'll still do that. It's just. So we figured out how to do it. I don't know. I don't know. It said that they were 2% on that. Because then she was.
The same thing.
So then times 2. So you take the and it's not. Yeah, that's pretty much all. Wait, but once you do the point two, like that's 0, and then you.
Judging from what I see in the class, I think most of you were actually quite okay with this assignment. So you can give yourself a pat on the back because this assignment combined many concepts all together. I don't know whether you realize that. All this while, we've been giving you, it's like baby food. I've been breaking it up into tiny pieces. Every one of these worksheets is very gradual. As I only introduce one thing, this one lumped together like everything. So it's actually good. Now, I will do this for you. I will reopen it. Give me some time after I go home in sometime in the afternoon. I'll open it again for you to do another attempt if you want to. If you need more time, I'll give you from the afternoon all the way to the evening. I'll send an email about it, so you can redo it if you want. You can even do it with your friends if you can meet up, or you can do it on your own. All right. Don't worry if you say, "Oh, what if I do worse on the second attempt?" The way Moodle works is it takes the highest score, so you can try again at no cost to you. Right? If you feel that, oh, if I just had more time, I could have done that. Well, you get the chance to do that. So let. Is your question?
Would you be able to put the like the slides, like all the finished slides in the middle?
Oh, okay. Now let me explain. The reason why I don't do that is because I feel that if I always put all the finished slides on Moodle, it will result, I think, in most people not copying stuff down. So that actually decreases the learning that you do in class. But so what I do is I allow students to take pictures and then we complete it. I hope you understand. That's actually the reason why. It's not because I'm trying to be funny or evil or what. It's not that. Okay. So just be watching your email. You will get the chance to do it again if you want to. All right. So I think for now, I will just quickly review the things that I expected you to be able to know. Let's look at the applet together. Why don't you tell me what goes in the probability of heads in the Ohio context, right? Can you tell me what number should have been there? What number should have been there in the probability of heads? 0.6, good. Why not 0.61? Because that's observed, and are we interested to test the status quo is 0.61? No. That is the most difficult thing for students to get, and if you can get that, that's really good. There's always a blue number, there's always a red number. The blue number is 0.6. Where does 0.61 go? Can anyone tell me which box do you put 0.61 in when you are in proportion mode? Can you tell me which box should you put 0.61? The thing that you saw? Yes. That's right. The one as extreme as what you saw. That's right. Then don't forget to actually simulate. Put 1,000. Okay. Sample size I think is pretty basic. Most of you know. And then get your p-value. Now, theory Z, you need the formula, which you have on that sheet of paper, right? In fact, I would recommend today, before you hand in at the end of class, take a picture because these are formulas that are very important, and you should start building your database of formulas because I allow students to have cheat sheets for exams, so you can take a picture of your own work if you want before you hand it in to me. And the other thing I want to say is. And I hope you realize the theory p-value comes from the z-table, and you can only get that after you calculate the z statistic. So everything goes one after the other like that. So I've tried to give you. I'm quite pleased. What I've seen is I think most of this class is not really struggling with these things, which is good because I've had classes where they look at this and everyone just flew to pieces. Well, I can't do this. Yes, there are more things put together, but I think you all are getting it, which is very good. Just remember, there's always a red number, there's always a blue number. The blue one is the hardest to catch. The status quo is the most abstract thing, and if you can clear that hurdle, that'll be good. All right. Okay, very good. I'm quite pleased with what I've seen. Well, I hope I'm not overly optimistic, and when I look at the grades, I'm like, oh man. Okay, but I think the class was pretty okay with this assignment because professors get a vibe from something. So I hope. But anyway, you can get to redo it today. Right? If you feel that you could do better, you can redo it. Okay, so let's go to what I want to cover today. We're going to start chapter 2. And what I want to do is something a little bit different in the sense that I am I'm not going to go in order of the slides. I'll tell you why. I feel that we have some momentum, and sometimes when you make slides, right? Now I want to make a slight change in the order of the slides, so it doesn't matter. The slides are still the same, the notes are the same, but I'm not going to go right from page 1. I'm going to jump down to something different first, okay? So I'm actually going to start with this definition of a sample mean. All right, you can find it on the piece of paper I asked you to print out. Is there anyone in this class who has never heard of a mean? I don't think it's possible. If you've gone to school at all, it is not possible not to know what a mean is. I think this is universal. How do you find a mean? You add up all the values of a quantitative variable and you divide by how many that you added up. That's it. Now, what about this symbol? Have you seen the symbol X bar before for mean? Okay, if you have not, well, here it is. The sample mean is typically written as X bar. And I would say this is something you observe as well. It's not p hat, it's different. It's a mean. All right, it's not a proportion, it's a mean. So I am slowly introducing now another observed statistic. Today, from this point, we're going to stop talking proportions. It ended with the Ohio Senate question that we did. We are now going to talk about means for the rest of the time. It's something new. A mean is not a proportion, but it's also observed. Hey, can I ask all of you a question? How tall are you? So everyone will report something. And can I calculate a mean from the class? Of course I can. So, but that's not a proportion. I didn't ask you a question that was yes or no. I didn't ask you whether you uh, did you have breakfast this morning or something like that. If I ask you a question that has a yes or no binary choice, that would be a proportion that I would calculate. Oh, okay. 43% of the class had breakfast this morning, and the others did not. That's a percentage, that's a proportion. But a mean is different. I could ask you, how tall are you? I get everyone's height, calculate a mean. That's not a proportion, that's a mean, that's called X bar. It's observed, all right? Good. So the sample mean is X bar. And why am I talking about this? Well, because I want to introduce the parameter version of the mean, and that's best seen by this example. So let me go to my own notes and show you what I'm talking about. Okay. If you look at the page 1 of the notes, we're going to skip the first part, as I said. Right? Those are pretty much quite basic, so I'm not going to talk about that right now. If you look at this chart, it's a dot plot actually. What is it a dot plot of? So I'll explain. Some students, I think it was in this school actually, they wanted to know what people's perceptions of time were. They wanted to know if people could basically tell how long something has been taking place. So they play a 10-second song snippet for people. So they say, oh, are you willing to participate in this very simple study? Okay, listen to this. Okay. Now, I believe, I'm quite sure they didn't tell them, oh, we're going to ask you how long you think it is. I think that's part of the point is they ask them to listen, but instead of asking them something like, do you know who the singer is or do you like the song, they suddenly, after you listen to it, they say, how long did you think the snippet was? And now, so bear in mind, the actual length is 10. The actual snippet was 10 seconds. And you'll find that most people kind of guessed correctly. Of course, there are people who think it was just 5. And somehow there are people who thought it was 30 seconds. This really puzzles me. Like there are 4 people. How can you mistake 10 seconds to 30 seconds? Okay. So one thing you might not know about me. How would you know? I can tell time intervals quite naturally without, like for example, if I go shopping in the supermarket, which I don't enjoy doing, by the way. But if you don't, you'll die because you can't eat. So uh, I know I've been there for 35 minutes. It's very weird. I don't know how I can do it. It's a strange superpower I have. Right? Without consulting a watch, I kind of know how long I've been doing something. But apparently these people are not like that. Right? They can't tell time at all. There's no sense of time intervals. But the point of this study was to show the distribution of times that people think the 10-second song snippet is. Okay, I want you to stare at the screen. Do you see the null and alternative hypothesis again? These are claims. But do you see a new Greek symbol here? Now, does anyone know what this is called? I'll give you a chance. If you don't feel bad because it's Greek again. Because parameters are always given Greek letters. Does anyone know what this is called? Okay, if you don't, okay, it's mu, okay? It's mu. This is the Greek M. This is the Greek M. Pi is the Greek P. This mu is the Greek M. It kind of looks like an M actually. That's where our M actually came from. Right? This is the Greek M. Why is this chosen? Because this is the mean. Mean. M. Okay. So mu. That's why mu was chosen. Now write your mu carefully, okay? Some students make their mu look like a pi. I don't even know how they managed to do that, right? Mu is mu, right? So mu. Now notice what is it? Mu is a population mean. X bar is something you can see. We give an English letter. That's the sample mean. The sample mean can be observed. We give it an English name, X bar. The population mean is something we don't know. I mean, do you know the mean? Uh, I mean, do you know the mean age of Michigan residents? You don't know. There are millions of us here. But it's a number. The mean age of people in Michigan is a number, but you don't know what it is. And things that you don't know that pertain to the population, we give a symbol, a Greek symbol. And now because it's a mean, we call it mean. Is that okay? So we are testing status quo is people can tell on average that it's 10 seconds wrong. The alternative is no, they cannot tell in general. So that's the only departure from what we already know. It's something very, very basic. So I think to motivate these things, I will immediately go to our data scratchpad, which we have not used very much of yet. Let me go to our data scratchpad, and I will call out. I want to show you. I want you to do something actually. So let me go to it first. All right. Um, Data scratchpad. Where is it? Okay. Okay, so we have not done this for a while. I'm going to go here. I'm going to call it sleep. I always like to motivate things with actual data. Can I have the class cooperate with something? And it shouldn't take long. Can I have everyone, starting from cell A1, don't put your name, please. Tell me how many hours you slept last night. If you can't remember, just lie. It's okay. Right? And don't agonize too much about it. This is just to show you how to do stuff. So can you just contribute to this page? Tell me how many hours you slept last night, starting from A1, then somebody else fill A2, and just give me in hours, and don't put a unit there, all right? Just give me a number, 7, 7.5, and things like that, all right? Thank you, all right? Yeah, unfortunately, this was me. I had 6 hours last night, not enough, right? I don't know about you, but if I don't have enough sleep, I pay the price the next day. Some people can get by with much less, but I 6 is bare minimum for me anyway. Good, thank you. I want to stop collecting data once I reach 20 something, all right? But I want to get at least 20 data points, all right? Someone can fill the first slot, it's okay, right? That's okay. It's don't leave gaps because that can be problematic. Thank you. I think I'll close it in a few seconds, right? So let's just have a few more. Thank you. Okay, and then maybe one more, all right? Then we'll stop it, all right? Just one more, okay, and I won't scroll there because I don't want people to be pressurized and oh, okay, so are we done? I think Okay, I tell you what I'll do is I'll move this up here. Okay, I'm gonna, anyone want any more? Last call, all right? If not, we'll stop it, all right? That's it. Okay, don't add anymore. So here's our data, all right? How do you find the mean? Okay, so this class is a stats class, obviously. So I'm going to teach you how to do these simple things on Google Sheet as well. You find the mean by doing this. Some of you may know this already. You just type equals, go to an empty cell, equals. Don't say mean, strangely, you have to say average. The function is called average. And you see, the computer is so smart now, they kind of know the cells that you want are A1 to A20. But if you want something else, just, and I'm going to pretend that we didn't have that thing. I'm going to show you. You just use your mouse and just select the data that you want. And let's hit enter. So what is our class mean statement? Oh, 7.2. Not bad. Okay. So I'm going to ask you, what symbol is 7.2? We just introduced it. Did I just calculate it from our sample? So what symbol do I don't want to type the word sample mean. I want you to give me the symbol. What is the symbol? It is a mean, but what's the specific symbol that we have introduced for the sample mean? Which is it? Anything that you can see, anything that you can see is given what kind of symbol? English letters or Greek? English. And therefore, 7.2 is something we have computed, we can see it. What's the name for 7.2? That's right, X bar. All right. So don't feel like, oh, why didn't I know that? Well, it's new, so I just introduced. This is X bar. All right. The next one I'm going to tell you is what's N. Now, I hope you all know this. How many people took part in this survey? I think there's 20, right? There's 20 of you. Now, if you cannot count up to 20, you can even use a function to do that. I'll show you. Equals count. You can even ask Google to count how many. Now you may laugh at this because it seems very stupid to do this in this context. However, if you have more complicated data where you have, oh, one group has this many people, another group, it can be a pain to identify how many people are in a particular group. We will see this next time. So this count function is actually quite useful in its own time. Not now. Now it's pretty obvious you can just fill in 20 on your own. All right. The other number I want to introduce is the standard deviation. Don't you want to know the standard deviation of the sleep times? How do you find the standard deviation? You go to equals, is a formula, and you do STDEV, okay? STDEV, STDEV, right? So STDEV gives you the standard deviation. Don't ask me why, okay? These are built-in function names. You have to follow them. So STDEV, and that's your STDEV. What's the symbol for the STDEV? Now, is this again something that we just calculated? Do we get to see it? Yes. So it's going to get an English letter. Anyone have any guesses? What is the symbol we introduced? It's an English one because I've just calculated it. I know what it is for our sample. What does anyone guess is the symbol for the standard deviation? Yes, S. That's it. Plain old S. That's it. Are we good? So now I'm going to introduce something, okay? You know that these things, what do we color X bar? What do we color an observed statistic? The thing that you get to see is always colored what? The thing that you get to see or calculate from the sample is always given what color? What color do we reserve for observed statistics? Always red. Always red, right? So therefore, I'm going to color this cell red. Because did I see it? I did. What color do we reserve for the standard deviation? Yes, good. Green. So here you go. Well, here you don't go. Why? Why do these things happen? Like, is it, or maybe because someone was there? Maybe. Okay. Can you put back the number? STDev. Anyway, the standard deviation is green. Good. So I am going. Why did X bar change? Someone deleted their sleep hour. Oh, don't do that. Right? It's okay. It's not consequential. I'm not going to go back. I don't even know who filled what. Right? Ooh, sample space. Okay. I'm just gonna. I don't even know what was here. I'm just gonna say 8. Okay. Yeah, I think it was 8. Okay. So, okay. Now, anyone? How do you get back the standard deviation? You type equals what? Div, right? Like that. Okay. And what is going on? Okay. 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 I'm going to ask you a question. Can I dictate a status quo value of the mean that I want to test? Can I do that? In other words, what I'm saying is, can I say, I want to see whether in the long run you are sleeping a certain number of hours that the population sleeps on average like that. My question to you is this. What color should mu be? Mu is a number as well. If I'm going to hypothesize about mu, what color do hypothesized status quo things take? Anyone? This is an exact analog from your proportion world. These are not proportions, I know. But what color should mu be? Blue. Good. This is the parameter value that you hypothesize. See, the concepts are the same. It's just that now we are dealing with another parameter. And the good news is this. There are only 2 parameters in this class. Either pi or mu. But you need to know what road you're on. How do I know that okay, and I could test anything I want. Can I test that mu is 6? I could. This means I want to see whether this class is sleeping the same number of hours on average as the population, which is 6. This, as I said before, is the most abstract part of statistics which students find very difficult to understand. X bar is easier to understand because you get to see it. But this is the status quo that you're comparing to. That depends on the researcher. What are you trying to test? It's just like that Ohio question I gave you. The 0.61 was what you saw. But the 0.6 was some point of interest that I'm interested in. See? So this one is, I'm interested, can I change this to 7? If I wanted to test 7, could I change to 9? I could, anything. See? Good. All right. So I wanted to get these things across. The last thing I want to say is, how do I know that in this context of this kind of data, that I'm not interested in p hat anymore? How do you know I'm interested in x bar? How can you get a p hat from this kind of data? The way the question is phrased doesn't allow you to even think about a p hat. Now, let me explain. If I ask you, how many hours did you sleep last night? Do you say yes? No, you don't. That makes no sense. How many hours did you sleep last night? Yes. Now, if I ask you, did you sleep well last night? Then you say yes or no. Did you sleep last night? Then you say yes or no. The yes or no questions lead to proportion considerations because then it makes sense to say, oh, p hat is, here's the fraction of people that slept last night or who slept well last night. But this is not a yes or no question. This number is quantitative. Quantitative data leads naturally to discussions about a mean. That's very, very important to understand. Is that okay? Now, the good news is a lot of what we have learned carries over. So let's go back to our notes now. A lot of what we have learned carries over to here. We'll skip this part first. I want to, okay, don't worry, I'll come back to it. I want to introduce this. We test hypotheses about a mean via a new standardized statistic I want to introduce. You calculate what's called the T statistic. I can't tell the class why it's called the T statistic. You have to trust me on this. Technically, it follows a different distribution, that's why. But it's also a standardized statistic. Right? You don't need to worry about why is it called T. It's not Z, it's T. But you will realize in my next slide, which I'll show you, that this is something that you are very familiar with. Do the colors help? Have you seen this kind of scheme before? Red minus blue over green? Look back at what I asked you to write on your table today for the written sheet. Aren't standardized statistics always the difference between observed and hypothesized? Red minus blue over some kind of SB thing, green. And this is no exception. You have your red, which is what you see. You have your blue, which is what you hypothesize or status quo, and you divide by some kind of standard deviation thingy, which is green. Notice though, do you see a p hat anywhere in this formula? No, because I'm not talking about p hat anymore. I'm talking about x bar. X bar is also something you see. I can see a mean. So it's red not because it's p hat, it's red because it's observed. And the blue thing is not pi anymore, it's mu. It is a parameter. It is something you hypothesize. It's just it's not a proportion anymore, it's a mean. If you can make this distinction, you're already better than many introstat. There are many introstat students who cannot differentiate between means and proportions. They get them hopelessly mixed up. They are different things. A proportion is a percentage. A mean is the thing that you're using. It's an average. It's not the same thing. The concepts are the same. So we use red here because this is the sample mean that you see. We use blue here because this is the parameter value that you hypothesize, that you don't know, but you make claims, oh, I say mu is 6, and I want to test whether there's evidence for that. As we go on in class, these things will get clearer and clearer to you because they are highly repetitive. And then the green thing is some kind of standard deviation. Is this okay? Then you use your calculator, calculate this, and then you go consult another table to get a p-value, which we will talk about next week, not now. Can anyone guess what's the name of the table that I'm going to introduce to you to get the p-values from when you use a t-statistic? Anyone got a wild guess? Good, yes, t-table. Why? Because this is t. So the t statistic leads you to the t table. A z statistic leads you to the z table, like that. But the table will be next week because I don't want to. I've introduced this concept. I don't want to mix in something because that's more mechanical. You know, it's all areas and looking at lines and all that. So that is pretty similar to the z table. So are we good? So let's calculate the t statistic for our class data, shall we? And I don't know whether. I think it will be better if I import these things. Let me take a screenshot. Oh, no. Tell you what. Let me copy these cells and paste them onto our class scratchpad here. I prefer not to work on, I actually prefer not working on the Excel. It's paste unlinked paste. Okay. Here is our class sleep data. Oh man, can I come out of this? Oh yes, I can. Okay. Class sleep data. Okay. Can I have someone, if I want to test whether mu is 6, can I have someone tell me what theory T looks like? Okay, so isn't theory T something minus something over something? Can you start? Very good. See, I saw 7.2. Good. Red minus blue. See, blue 6. Okay, and then what goes in the bottom? Okay, I'll flash back to my notes if you want, but I think you probably copied down the notes already. See, here's the formula. Red minus blue over green. All Yeah, this is excellent. Yes, and don't forget the SQRT. Perfect. Very good. And what is this actually? Okay, so you can go check this one. That uh, well, that was really high. But I think they might be correct. I'm not saying it's wrong, but I'm saying that then you use this number in the T table next week, not now. Okay, so I want to ask you at this point, if you can, to fill in the rest of this table. Can you do it now for a mean? Now do the mean part. All right.
But now, yeah, I'm so sorry. I'll just call it my dad. Yeah, call me. I'm so sorry. You got anything?
Yeah. Wait. So, no, yeah, I think it's exactly. We don't change it. Just for the second. Oh, okay. That's okay. So,
Perfect. How do I know the null is new now? Or null involves because I'm talking about a mean. Because I'm now in the mean world, it's mean. So mu. Good. Yes, the observed stats are x bar, and there's a bunch of others I'm going to put in here. The observed stats are x bar, s, n. What do I color mu? Anyone? Mu has to be blue. Good. What do I color x bar? Is it something you observed? I mean, the word observed is already there. So red. X bar should be red. Okay. What's the formula for theory T? You can just quote. I want you to type it out here because a lot of math comes from writing things down or typing things down. That's right. X bar minus mu, good. And we know X bar is red. And we know mu is always blue. And then the formula, yes. And so the denominator is S over square root of N. And this whole thing is the variability. So I'm going to color this whole thing. What color am I going to use? Very good. Theory p-value comes from the very good. Good. And what color do we reserve for p-values? Yes. I'm trying so hard to make this a thing and I think it's working. P-values are purple. I know on the applet it's red. I haven't had the time. I will make my own applet, but your class will not be the one to use it. I'm sorry. All right. So next time I'll try to make one where it follows my color scheme. But for now, we have to pretend. All right. But anyway, theory p value comes from the t table, which we'll talk about next week. Very good. So if we can get all these things down, the rest of the class today will be lighter and easier. So I'm going to talk about the other things that I skipped on the slides. All right. I wanted to introduce these very crucial concepts today. But now let's talk about something else. So I want to introduce a few things. You know, we talked about a sample mean. I'm going to introduce the sample median. How many of you have heard of the median before? The word median, yeah, it's quite common. How many of you have seen this? Now, the symbols are not important, but I'll introduce that. The median tends to be written with a, this is called a tilde. It's not a bar. X tilde, right? X tilde. Um, it actually looks like, you know, when people wear I don't know what's the word for it, a hair piece or something like that. So it's like the wavy line on top. Looks like hair. Okay, so the median has this symbol x to this. The I will explain what this means. I'll give you a practical example. The median basically is found by sorting from small to big, and then you pick out the middle. That's why it's called a median. Right? You sort from small to big, and you pick out the middle. And the middle is defined as the n plus 1 over 2. Now, I know some of these things look kind of weird. Like if n is odd, then the median is the middle. If n is even, then the median is the average of the middle two. I will explain what all this is talking about in our own class data example. All right, we will talk about it. But I'll give you time to copy this down. Then we talk about what do we mean when we say data are skewed. Essentially, we say that data are skewed when a whole bunch of them, more than half, falls on one side of the distribution. I think this is not such a difficult or alien concept to most of you, right? Skewness just means not symmetric. Bell shape is symmetric. Everyone on either tail, both tails are equally represented. Skewed just means that one tail is heavier. There are more people on one side of the distribution. Okay? So I will come back to this slide. I think, yeah, I think that's actually okay. We will. This class is always so cooperative that I always try to be able to end early. I hope you all don't mind. Because I want to teach at the same rate. That's kind of why. Because I have two sections. Now let me just say something. I will teach you how to find a median now. We still have some time. Let me show you how to get the median. What does it mean? So let's use our class data, okay? So I'm going to teach you a few things, like how do you even sort data? Because before you can get a median, you need to sort. So don't disturb the original data. What I'm going to do is I'm going to copy these cells and go introduce a new sheet. And I'm just going to call this median, okay? Okay, so here's our data. Okay, so there's 20 of them, good. So first, how do you sort? These are all in random order. So what you do is select the cells that you want to sort, and Google Sheets is easier than Excel to sort. So you just go to data, sort range, not sheet. Okay, you don't want to sort the whole sheet. Sort the range from A to Z, small to big. And that is it. All right. That's how you sort. Now, at any time, if you forget any of these things, just ask me. Right? Google Sheets is a useful skill to know how to have anyway. And it's kind of embarrassing to actually leave a statistics class and not know how to use quite fundamental things in Google Sheets. That's why I make it a point to teach Google Sheets. It's not just about teaching you p-values and all. I want you to be able to use some spreadsheet stuff as well. Okay, so you have sorted it. So what does the rule say? So the median is according to my definition that you have copied down, it is the n plus 1 over 2 value, all right? But what does that even mean? Okay, what's n here? Didn't we have n equals 20? Right. So if you calculate 20 plus 1 over 2, what is this? 10.5, all right? So this means you need to find the 10.5 value to get the median. What does that even mean? How can you? Well, it means this. The 10.5 value is between the 10th and the 11th. So you go to the 10th value, which is 7. You go to the 11th value, which is also 7. And you actually, the median is the average of 7 and 7, which of course is what? 7. So you might say, then why am I giving you this complicated formula? Well, because sometimes you may hit a different number, then you average the two. Do you get what I'm trying to say? So if this had been 7.5, for example, then you average 7 and 7.5, and you get 7.25 as your. Is this okay? Now let's do another one. I know that this class contributed 20 data points, which so happens to be something that leads to this example. What if, all right? What if let's just do this, okay? What if the data had been this? This one, and okay. And let's say this point is not there. All right. Now, okay, now there are how many data points? 19. All right. According to my formula, n plus 1 over 2 is 19 plus 1 over 2, which is what? 10. The median is the 10th value here. Is that easy to do? That you don't need to average it out because it's an actual position. You see, there's no half thing going on. So you count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 10th value here is 7. So the median is 7. Is this okay? So I'm just trying to relate to you I'm trying to draw a relationship between what the slides say. See, if n is odd, which the second example was 19 is odd, then the median is just the middle. If n is even, which was our first example, then it is the average of the middle two. If you don't like these statements, just go with this one. I put this here because some people are more mathematical, they like this. Some people are less mathematical, they prefer something more intuitive. So I give it to you in two ways, but it's the same thing. Okay, so that's all for today. Have a good weekend. Make sure your names are on the watch your email because I will open up the group work until tonight for you to try again. And you don't lose anything by trying it. So just leave these in your front, okay? With your names on. Thank you.